Okay, so example 1.4. Now, the preceding explanation before this example is basically explaining why we need a constant of integration. So the reason is, so if I do a quick example here, so if I have y equals x squared and differentiate it, I get 2x, don't I? But if I had y equals x squared plus 1 and differentiated it, I would also get 2x. Or x squared plus 12, for example, and differentiate it, I would get 2x. Or let's change that to a negative. X squared minus 12 and differentiate it, I got 2x as well. So the point I'm trying to make is when you integrate, say 2x, so we can integrate it to get the function x squared. But how do I know if it was x squared plus 1 or x squared plus 2 or x squared minus 3? The answer is we don't know. So we stick on this plus c so to account for all those possibilities. This is representing a curve, and it's actually an infinite amount of possible curves. And the point of this example 1.4 is we're actually going to hone in, we're going to narrow it down and specify which specific curve we're talking about. If you think about this visually as well, so if I integrate 2x and get x squared plus c, so let's say I had x squared plus 1. We know x squared plus 1 differentiates to 2x, and this is what x squared plus 1 looks like. But so does x squared plus 0, or just x squared, or x squared minus 1, right? So all of these three, so let's say that's x squared plus 1, x squared minus 1, just for a bit of symmetry. All of these differentiate to 2x. All of these curves have a gradient function of 2x. So we stick a plus c at the end to kind of like represent that idea of it being any possible curve. This just translates the curves up or down, doesn't it? So it vertically translates x squared by the vector 0, c. Okay, so in example 1.4, so we're given the gradient of a curve is given by dy dx is equal to 12 root x, and we're told that the curve passes through a point 4, 50. Okay, and that's going to allow us to specify what the specific curve is. So the first thing we need to do is integrate it like normal, like we've usually been doing. So I'm going to just rewrite root x as x to the half. Okay, so we have to be familiar with our indices in this topic. So root x is the same as x to the half. And now I can integrate it, so hence why I'm writing y now. So I'm going to write 12x, but now I'm going to add 1 to the power, so a half plus 1 is 3 over 2. I'm going to divide by the new power 3 over 2, and I'm going to add on this constant. So I did that mentally, a half plus 1, but if you're not sure, it doesn't hurt to just do a bit of working out to the side. So a half plus 1, you could think of as a half plus 2 over 2, so 3 over 2. Or another trick I like is, well, a half is 0.5 plus 1, so that's 1.5. But we do like fractions in A-level maths, so we need to get used to the idea of fractions. And like all the exams are calculator based anyway, so you could just do a half plus 1 on your calculator. However, I do think it's important that you develop some mental maths skill in A-level maths. So try and do things mentally as much as possible is what I'd preach. Okay, so anyway, we still need to simplify this. And another thing that I've noticed trips up students sometimes is like how to actually simplify fractions like this. Because this is 12 over 3 over 2. So I think the simplest way is to just do 12, circle that 12, circle the 3 over 2, and do 12 over 3 over 2. So 12 divided by 3 over 2. And when you divide, you change it to a times, and you change this to the reciprocal. Some of you might be aware of KFC, not the fried chicken place. The method, keep, flip, change. Keep, flip this fraction and change it to a times. 12 times 2, I can do this trick as well. 12 times 3 is 24. 1 times 3 is 3. 24 over 3 is 8. So this basically becomes 8x to the 3 over 2 plus c. Now, as this curve, this is the original curve, which has gradient 12 root x. We actually know where it passes through. Now, whenever an equation, we know a curve passes through a certain point, that means this equation has to satisfy x equals 4, y equals 50. Because you could think of this as, you know, an xy coordinate. So I'm going to substitute in that coordinate. So when x equals 4, y equals 50, and that gives me 50 equals 8 times 4 to the 3 over 2 plus c. And now I'm going to follow my own advice and try and do this mentally, but you can use your calculator at this stage. So because of BIDMAS, I have to do the indices first. So the bottom of the root set. Square root of 4 is 2, 2 cubed is 8, 8 times 8 is 64 plus c. Rearranging for c, I get negative 14. And so the final answer is, because the question said find the equation of the curve, y equals 8x to the 3 over 2 minus 14. So I'm just writing this again, but with my c subbed in. Okay, so hopefully you got some benefit from that, and that kind of makes sense. So very common type of question that comes up. If you sift through exam questions, EdXL, AQA, past papers, new spec and old spec, you will see similar questions. Okay, thank you.